Woohoo! Welcome back. Today we're going to be talking about Descartes' Rule of Signs. Woohoo! Now this is just a little snack of a rule, and to be honest, if you're reading this for the first time, it would be terribly appropriate just to burst out in laughter. Let P be a polynomial with real coefficients. Now we're starting to get somewhere interesting. So we're into real coefficients. Ooh. And it says the number of positive real zeros, remember we're talking about real zeros of P of x, either is equal to the number of variations in sign in P of x or is less than that by an even whole number, 2, 4, 6, etc. Okay, and then number 2, the number of negative real zeros of P of x either is equal to the number of variations in sign in P of the opposite of x or is less than that by an even whole number, 2, 4, 6, etc. Now, I understand, and I completely understand if reading that you're just laughing in a historical sort of sense, because this does not seem like it makes any sense. But again, this is just a little snack of a little helper, and it's the reason we include it is it's a very quick check. So if we have a polynomial, here we have a polynomial, then what we do is it's just really quick. We say, okay, so this is plus, this is plus, this is plus, this is a minus, and a minus. And when you look at those, do you have any changes? And the answer is absolutely. From here to here, you have one change in sign. These are all positive. This is negative. So there's one change in sign. We call it a variation, but it's just a change. So that means there is one real, positive real zero. Okay, so what does that mean? That means that if you're going along and you find one positive number, which is a 0, you're done. Stop looking at positive numbers. This is really helpful. This you can do just by looking at it really fast, and it can keep you from having to check a bunch of numbers. If you have 16 possibilities and you find one that works, you're done, right? So this is why we're including it, even though admittedly when you read this, it may not make as much sense at first. Now, the second part takes a little bit of work. So this one is the one people are often like, I don't know if it's worth it. So you get to decide when you're being asked to solve these problems, which we're going to do at the very end of the section. We're going to do a big whole problem that will use all the different rules. But for this one, it may be that you're like, I'm not sure this is worth it. But it's not that, it doesn't take that long. So what you're going to do is you're going to pop in the opposite of x. So I get 3 times the opposite of x to the 6th plus 4 times the opposite of x to the 5th plus 3 times the opposite of x cubed minus the opposite of x minus 3. And you notice that for this, we do not consider the zeros. So I should have mentioned it earlier, that x to the 4th that's a 0, that isn't a variation in sign, because 0 doesn't have a sign, so we don't count that. So we're going through, and we've got, let's see, even exponents erase the sign, right? The opposite of x to the 6th is just going to be 3x to the 6th. Odd exponents preserve the sign. So this is going to be minus 4x to the 5th. Then this is going to be minus 3x cubed. This is going to be plus x minus 3. So let's look at the signs. This is a plus. This is a minus. This is a minus. This is a plus. This is a minus. We've got a variation here. We've got a variation here. And we've got a variation here. This is 1. There's 2. There's 3. So then we've got 3 negative real zeros And then there's this one other thing that says or is less than that by an even whole number. So if you found 3, you could also have 1. So altogether, there are either 1 plus 3, 4 real zeros, or 1 plus 1, 2 real zeros. And then if we look at this, how many zeros should there be? There should be 6. So if there are 4 or 2 real zeros, what are the other ones? The other ones are going to be imaginary, complex numbers. So, dun dun dun, there you go. That's your little Descartes snack. I think, therefore I do math. Woohoo, yay Descartes. Okay, that's it. In the next video, we're going to learn another little snack, and then we're finally going to wrap it all up into one big, awesome, just delicious feast of a problem. So, make sure you're getting enough snacks in the real world. Get some hydration, you know, dance and sing and do all the fun things that you can do, and then come back and see me for the next video. Woohoo! Math on, you awesome, beautiful people, you. Woohoo.